Hello students, Dr. T is here and welcome to chapter 1, Matter, Measurement and Problem Solving. In this chapter, we will explore how chemists think, how we classify matter, and how we use measurements to understand the world at the molecular level. So, if you have to choose the single most important scientific idea and all of human knowledge, it will be like the properties of matter are determined by the properties of atoms and molecules. Everything we observe, like water flowing or sugar dissolving, metals bending, come from what happening at the atomic level. So atoms and molecules determine how matter behaves. If they were different, they would behave differently. The properties of water molecules determine how water behaves. Boiling point, freezing point. The property of sugar molecules determine how sugar behaves. For example, how sugar dissolves in water or in oil. The understanding of matter at the molecular level gives us understanding or an unprecedented control over the matter. So atoms are tiny particles that make up or generate matter. So don't trust atoms, they make up everything. So see this very thin sheet of paper, right? I need zillions of atoms to form this. So this is how tiny an atom are. Most atoms don't exist by itself. They bond together like to make or to form molecules. A single oxygen atom almost never exists by itself. So two atoms bond together to form O2, a molecule with a very specific shape. You don't breathe individual oxygen atoms. Actually, oxygen atoms pair up in a precise arrangement to form O2, the molecule your body gonna use it. For example, every water molecule, we have 2 hydrogens and 1 oxygen, right? So, and if I change that, if I write like, okay, I have 2 hydrogen and 2 oxygen, you already know that that is not water molecule, right? That compound will have different properties because now I have 1 oxygen more. So each molecules will have a certain quantity of each atoms, and that is what forms those molecules, the identity, the properties. So understand these structures is the heart of chemistry. Even small change in atomic arrangement can create complete different materials. Like I said, if I have H2O, I can tell you that's water, and you already know since you're a baby probably. But if I tell you that I have H2O2, you know that is not water. You don't know what is that, but for safety, you know that you cannot drink that because that is not water and that will have different properties. And when you have small changes in atomic arrangement, so you could have the same number of carbon, for example, together, but they can arrange different and create different materials like graphite and diamond and graphite. So the atoms are arranged in shells and sheets. I'm sorry, I said shells and sheets. By contrast, the atoms, if you see here in the figure, so when you see the diamond, they are all bound together, forming the three-dimensional structure here, and they are completely different, but they are formed by carbon. So the arrangement change completely the properties. Okay, so and when you study something in science, we use the scientific methods. So chemistry is based on observation and experimentation. So first, you observe. So you get a liquid here. I can say, okay, this is a clear it's a liquid and it's clear. and if I open, I cannot feel any sand. So this is observations. But if I want to study a little bit more, I need experimentation. So scientists start by noticing something, asking questions, and forming hypotheses, a tentative of explanation. Experiment tests the hypothesis. If the results are consistent over and over, we may develop a scientific law, which describes what happens. If we build a deeper explanation supported by lots of evidence like why that happened, we develop a scientific theory which explains why something happens. So, observations are also known as data. They are description about the characteristics or behavior of nature. Observations often lead scientists to formulate a hypothesis. So the hypothesis is a tentative interpretation or explanation of the observations. For example, Lavoisier explained his observations on combustions by hypothesizing that when a substance burns, it combines with a component of air. A good hypothesis is falsifiable. The results of an experiment may support an hypothesis or prove it's wrong. In each case, which case the scientist must modify or discard the hypothesis. For example, I'm a scientist and I produce ethanol from waste. So the first thing that I need in my waste is the main important thing is the sugar present in that waste. And imagine if I'm here and I need to write down a new project and I'm looking through my window and I see a tree over there and the birds are eating the seeds. Something that we don't eat, so it's not food, human food, but the birds are eating. Oh, maybe that has sugar on it. So the first thing is the observation over there, right? And so if that has sugar, I can produce ethanol with that. So then I need to go to the lab and prove that I'm right or wrong. So if I'm wrong, I will discard that and say like, okay, don't try those seeds because I have done like several experiments and we cannot recover the sugars from that. We cannot break down the wall to release that sugar. Okay? So a scientific law, so a law will describe what nature does. So a brief statement that summarizes past observations and predict future ones. Law of conservation of mass, for example. In a chemical reaction, matter is neither created or destroyed. This allows us to predict future observations. So you can test law with experiments. Unlike civil or government laws, you cannot choose to violate scientific law. So if I'm telling you that is a conservation of mass, you're gonna break down this law. You know that if I put like 100 grams of hydrogen, 100 grams of oxygen, I will produce something at the end that are gonna have 200 grams. So that is a conservation of mass. Okay, maybe you're thinking like, oh, what about gas? The gas we will skip. So when you're talking about science, we're talking about closed system. So it's everything inside. So even the gas that you're producing, you account that. So you have the mass of that. Okay, so that is a conservation of mass. A theory explains why nature behaves that way. Okay, so one or more well-established hypotheses may form the basis for a scientific theory. So theories can never be conclusive, proving, because it's some new observations or experiment always has potential to reveal a flaw. Okay, so this is why we keeping studying. So if someone tells you, okay, unfortunately we don't have a cure for cancer, so some other scientists will go to the lab and will try to find a way to cure the cancer and try to prove the other theory, that is the theory that other scientists, and prove that they are wrong, so we can cure this disease. Okay, so it's really important to understand the difference between those. If you look to this diagram over here, the approach begins with the observations, right, that lead to hypothesis or a law. So a hypothesis can also lead to a theory, right? Hypothesis, law, or theory is tested using experiments. Experiments may confirm or revise a theory, right? Or revise the hypothesis, law, and theory. So this diagram it's really about how science builds reliable knowledge. So when you look to this, you notice that we don't have a straight line over there, right? We have a cycle. And emphasize that science is based on evidence, not opinion or authorities. Here's the idea in a way you can understand better. So science is empirical. And empirical means based on observations and experimentation. Scientists don't guess or rely on beliefs. They look at what nature actually does. For example, if you heat water, it boils. This is an observation. If you measure how temperature affects boiling, that's an experiment. See the difference? So the scientific method is a process. So we start with the observation. So you notice something interesting or unexpected. For example, a metal gains mass when it rusts. A hypothesis. You propose a possible explanation for that. For example, maybe the metal is combined with something else in the air. Okay, so an experimentation, you will test your hypothesis with controlled experiments. For example, we burn metal in a closed container and measure the mass of if that mass will change after you burn. So laws and theory, if the results are consistent, a law will summarize what happens, and the theory will explain that. Okay? So this is very important. So let's review your knowledge over here. So it's a time for a quick understand check. So which statement best explains the difference between a law and theory? So a law is a truth and theory is a mere speculation? Or a law summarizes a series of related observations? A theory gives the underlying reason for them. So a law is like what happened, and theory explain why it's happening. So, and C says a theory describes what nature does, and a law describes why nature does it. So, what do you think? Press stop and answer the question. Right. B. A law summarizes a series of related observations, while a theory gives the underlying reasons for them. Good. So, the classification of matter. So, since at the beginning we start talking about matter, because chemistry is the study of matter. Everything that has mass and take up space are matter. Your textbook, your desk, your chair, and even your body are all composed of matter. We are pure chemistry, all right? So we can classify matter according to its states. Physical form, if it is solid, liquid, gas, and its composition, the basic components that make it up. Okay, so we have, that matter can be classified as solid, liquid, or gas, and based on properties that each substance contains. For example, I know this is solid, right? It's solid because all the atoms are packed tightly together in a row and the columns like you see over here. But when you go to liquid, the atoms are a little bit far away from each other. Not too much, but they have freedom to move a little bit. So when you look to the gas, the air I'm breathing here, the air that you're breathing there, is very light because the particles are very separate from each other. So it's one molecule over here, another over here. So the atoms are moving around, or the molecules like O2 are moving around. They have space to move. Okay, so they are able to move freely. We're going to pass through like solid, liquid, and gas. I know that you already know those properties, but it's important to review. You know that in solid matter, atoms are all packed together. That's why we have a solid, right? So they are very close to each other. So the atoms and molecules in a solid vibrate. They don't move around like in a gas, passing to each other. Consequently, a solid has a fixed shape, right? So rigid shape. So I cannot change this. I can put all these in a ball and it will not get the form of the bottle because they are fixed shape and rigid, like ice, aluminum, diamond are example of those solids. So the solid matter may be crystalline, and in which case the atoms or molecules are in patterns with long range repeating order, like table salt or diamond are example of those crystalline solid matters. And we have amorphous, so which case that atoms or molecules don't have a knowledge range order. So they are like in different ways. I need my pen here to explain this better for you. But here you can see the diamond. So they are very well organized, right? This is a crystalline way to organize the atoms. However, some disorganization that we call amorphous, the atoms don't have any long range order like we see here in the crystalline, like a glass and plastic are example of amorphous solids. The liquid, we know the atoms or molecules pack about as closely as they do in solid matter, but they are free to move relatively to each other. They have fixed volume, but not fixed the shape. If you put the water inside of a vase, like in different form, they will get the form, the shape of the vase, or the shape of the cup, or the shape of whatever you use to store your water. So liquid ability to flow makes it assume the shape of its container, like water, alcohol, gasoline, or all substances that are liquid at room temperature. And the gaseous matter, atoms or molecules have a lot of space between them. They are free to move relatively to one another. These qualities make gas compressible. So the classification of matter by components is according to its composition, elements, compounds, and mixture. And this we will talk a little bit more in the second part of this chapter. For now, that's it. That's all. Bye for now.